What do you think if a human has 3 eyes or 2 brainless heads? Sounds impossible, right? You're probably picturing a monster, and stop laughing at me. You also look like a monster if this is possible. Now imagine seeing real people who actually have unique and the strangest body parts ever recorded, whether it can be 2 extra fingers or something else. Sounds odd, but believe it or not, some of these superhumans have lived and are living among us, eating, sleeping, and existing just like everyone else. And today, we're diving deep into some people that has the most unique body parts. So, get ready for a journey full of curiosity and pure amazement you won't forget. Number 15. Lakshmi Tatma, extra limbs. Lakshmi Tatma was born in India with a highly unusual anatomical condition caused by a partially developed parasitic twin. This resulted in 4 arms and 4 legs attached to her torso. Parasitic twinning is a rare type of congenital anomaly in which an incompletely formed twin becomes physically attached to a fully developed sibling during early embryonic development. The extra limbs in Tatma's case were non-functional but structurally complete, creating significant medical and mobility challenges. Advanced imaging techniques, including MRI and X-rays, were used to map the skeletal and vascular connections before surgical intervention. In early childhood, surgeons carefully removed the additional limbs through reconstructive surgery, preserving her nervous system and major blood vessels. The procedure required meticulous planning to avoid complications and to maintain normal development. Cases like Tatma's are studied in embryology and pediatric surgery because they illustrate how early-stage cell division and developmental pathways can produce complex anomalies. Her situation has contributed to discussions on surgical techniques for rare congenital malformations and the coordination required among multidisciplinary surgical teams. Number 14. Abby and Brittany Hensel, conjoined twins with 2 heads. Abby and Brittany Hensel are conjoined twins born in Minnesota, USA, sharing 1 body with 2 separate heads. This condition, medically classified as dicephalic parapagus, occurs when identical twins partially separate during early embryonic development, leaving them physically joined from the torso downward. Each twin controls 1 side of the body, coordinating movement for walking, running, and daily activities. Despite sharing organs such as a heart and liver, the twins have distinct brains, allowing individual control of limbs and head movement. Extensive imaging studies, including MRI and CT scans, have documented the layout of shared and separate organs, which is critical for understanding the physiological challenges of dicephalic parapagus. Physical therapy, coordination training, and specialized schooling strategies have been developed to maximize their mobility and independence. This case is of significant interest in anatomy and neuroscience, as it provides insight into how 2 brains can independently manage a single musculoskeletal system. Abby and Brittany's daily life demonstrates the remarkable adaptability of neural control in shared bodies. Number 13. Manor Majid, 2 heads. Rare occurrences in embryonic development can result in craniopagus twins, where 2 heads form on a single body. Manor Majid, born in Egypt, exemplifies this condition, having 2 fully developed heads attached to 1 torso. Each head contains a separate brain, allowing independent control of sensory input and motor functions for its respective side of the body. Shared organs include the heart, lungs, and digestive system, which require coordinated internal function to maintain health. Surgical intervention is highly complex in such cases, often focusing on ensuring proper organ support rather than separating the heads due to the high risk involved. Imaging technologies such as MRI and angiography are essential to map shared blood vessels and organ connections. Studies of craniopagus twins like Manar provide valuable insights into neurological coordination, organ sharing, and prenatal development, highlighting how the body adapts when 2 neural systems must operate a single set of organs simultaneously. Number 12. Edward Mordrake, second face. Edward Mordrake was reportedly born in England in 1831 with a highly unusual condition, a second face on the back of his head. The extra face appeared fully formed with eyes, a nose, and a mouth, though it lacked functional brain tissue. Historical accounts suggest that the secondary face could move independently, creating a visual expression of smiles or frowns. While modern medicine questions some details of the story, cases of craniofacial duplication, or diprosopis, are extremely rare and arise from abnormal activity of the protein SHH, sonic hedgehog, during early embryonic development. Mordrake's condition attracted attention from physicians and researchers studying congenital craniofacial anomalies, highlighting how early developmental disruptions can produce complex duplications of facial structures. Documentation from the 19th century includes observations of social and functional challenges caused by the appearance, as well as speculation on neurological connections between the main and secondary facial structures. Ready for the unbelievable? Let's move on to the next case. Number 11. Gemma Arterton, extra fingers, polydactyly. Gemma Arterton, born on January 2, 1986 in Gravesend, Kent, England, was born with 2 extra fingers on each hand, a condition known as polydactyly. This congenital anomaly occurs when the embryonic limb bud produces additional digital rays during early development. In Arterton's case, the extra digits were non-functional and were surgically removed during infancy to allow normal hand function. Polydactyly is one of the more common congenital hand anomalies, occurring in approximately 1 in 500 to 1 in 1,000 live births, and can appear on either hand or foot. The condition can be isolated or associated with genetic syndromes, though Arterton's case was isolated. Surgical correction involves careful excision of the extra digit and reconstruction of tendons and skin to preserve full range of motion and dexterity. Cases like this provide insight into limb development, digit formation, and surgical techniques for restoring normal anatomy in congenital limb anomalies. Number 10. Harry Styles and Mark Wahlberg, supernumerary nipples. Both Harry Styles, born February 1, 1994, in Redditch, England, and Mark Wahlberg, born June 5, 1971, in Boston, Massachusetts, exhibit a congenital trait known as supernumerary nipples, or accessory nipples. These extra nipples are small, benign formations along the milk line, which extends from the armpits to the groin. Supernumerary nipples occur in roughly 1 to 5% of the population and usually remain asymptomatic, although some may be mistaken for moles. They result from incomplete regression of embryonic mammary ridges during fetal development. In most cases, they do not interfere with function and require no medical intervention. In celebrity cases like Styles and Wahlberg, the accessory nipples have become part of public awareness due to visibility in media appearances. Clinically, supernumerary nipples are significant mainly for differentiation from skin lesions and monitoring for rare instances of pathological changes. Studies of accessory nipples contribute to understanding mammary ridge development and variations in human embryogenesis. Number 9. Karolina Kurkova, unique belly button. Born on February 28, 1984, in Děčín, Czechoslovakia, Karolina Kurkova is a supermodel notable for lacking a conventional belly button. This unusual feature resulted from complications during umbilical hernia surgery shortly after birth, which altered the normal formation of the navel. The navel, or umbilicus, is typically a remnant of the umbilical cord, formed when the cord stump heals after birth. In Kurkova's case, the absence of a typical belly button is purely cosmetic and does not affect internal anatomy or organ function. During fashion shoots, digital editing is often used to create a visually standard navel. While rare, anomalies of the umbilicus can include absence, unusual shape, or outgrowths like umbilical polyps. Studying such cases contributes to understanding normal and abnormal postnatal healing of the umbilical region, variations in soft tissue closure, and aesthetic considerations in reconstructive or cosmetic medicine. Her condition highlights how minor congenital variations can become notable in public or media contexts. Number 8. Chandra Oram, tail. Chandra Oram, an individual from West Bengal, India, was born in 1986 with a rare physical anomaly, a tail-like appendage extending from his lower spine. This structure consists of skin, connective tissue, and cartilage, lacking vertebrae and functioning primarily as a visible growth rather than a true tail. Oram's birth year, 1986, places him among the few documented modern cases of vestigial human tails, which arise due to incomplete regression of the embryonic coccygeal projection during development. While such tails are typically removed surgically for medical or cosmetic reasons, Oram has retained his tail, making it a subject of study in developmental biology and genetics. Researchers examine these cases to better understand the molecular mechanisms controlling regression of embryonic structures, particularly the signaling pathways that determine coccyx formation. Oram's condition demonstrates how rare developmental remnants can persist into adulthood without affecting major organ systems, providing insight into vestigial anatomy in humans and the variations that can arise during fetal development. Prepare to be amazed again. The next story takes it to another level. Number 7. Myrtle Corbin, 4 legs. Myrtle Corbin, born in 1868 in Lincoln County, Texas, entered the world with 4 fully formed legs, a condition resulting from a partially formed parasitic twin attached at the lower torso. Unlike typical conjoined twins, Corbin's extra pair of legs were non-functional but anatomically complete, extending from the pelvis alongside her own. Medical observation at the time documented how the legs shared skeletal structures and connective tissue with the main body while remaining largely immobile. Surgical intervention was not performed during her lifetime, but she lived a physically active life using adaptive movement techniques. Cases like Corbin's provide historical insight into parasitic twinning and embryonic limb development, illustrating how incomplete twin separation can result in duplicated lower limbs. Her condition contributed to early studies in anatomy and congenital anomalies, influencing both surgical approaches and medical classification systems for twin malformations. Number 6. Wen Zhengrong, extra fingers. Extra digits on human hands are among the more visible congenital anomalies, and Wen Zhengrong from China, born in 1992, demonstrates this with multiple additional fingers. Some of these digits are fully functional, with independent movement, while others are less developed. Polydactyly arises during early embryonic development when the limb bud produces extra digital rays, often influenced by genetic signals. Medical evaluation typically involves imaging techniques such as X-rays to assess bone formation, tendon attachments, and potential interference with normal hand function. Surgical options depend on the location and usability of the extra fingers. Functional digits can sometimes remain, offering unique dexterity, while non-functional ones may be removed for improved hand utility. The condition occurs in roughly 1 in 500 to 1,000 births and can appear in isolation or as part of syndromes. Wen Zhengrong's case is significant for understanding limb morphogenesis, human anatomical variation, and the role of developmental genes in shaping digits. Number 5. Diego Medina, extra toes. Variations in the number of toes are uncommon but medically documented, as in the case of Diego Medina from Colombia, born in 1995. He exhibits polydactyly of the feet, with 1 or more extra toes present alongside the typical 5. These additional digits form due to irregular signaling in the embryonic limb bud during fetal development, causing extra digital rays to emerge. X-rays and clinical assessments help determine the structure of the bones, the connections to tendons, and whether the extra toes interfere with mobility or balance. Surgical removal can be considered if the extra toes cause discomfort, difficulty walking, or functional issues, but in some instances, they are left intact if they are fully functional. Cases like Medina's contribute to understanding skeletal development, congenital variation, and the genetics of limb formation. Studying foot polydactyly provides insight into human anatomical diversity and how minor deviations in embryonic signaling can lead to permanent structural differences, highlighting the complexity of limb morphogenesis. Let's dive deeper into the unusual. Here's the next person to discover. Number 4. Victor Hugo Peralta and Gabriela Peralta, body modifications. Victor Hugo Peralta, born in 1975, and Gabriela Peralta, born in 1978, are a married couple recognized for holding the Guinness World Record for most combined body modifications. Together, they have undergone more than 90 modifications, including piercings, subdermal implants, and tongue splitting to create a forked tongue. Body modification involves deliberate alterations of the body's surface or structure for aesthetic or personal expression, requiring careful surgical precision to avoid vascular or nerve damage. Each procedure demands meticulous aftercare to prevent infections and ensure proper tissue integration. Their case provides insight into how human tissue adapts to repeated invasive procedures, the limits of healing, and the interplay between skin, connective tissue, and implanted materials. Studying extreme modifications like those of the Peraltas helps medical and anthropological research on human body adaptability, long-term tissue responses, and the cultural and social aspects of body alteration practices. Number 3. Yu Zhenhuan, extra nipples. Extra nipples, or supernumerary nipples, are a rare congenital variation along the embryonic milk line, and Yu Zhenhuan from China, born in 1987, exhibits this trait. Unlike typical nipples, supernumerary nipples may be smaller, underdeveloped, or occasionally functional, but they rarely interfere with normal physiology. In Zhenhuan's case, several additional nipples appear along the torso without impacting organ function. This condition results from incomplete regression of mammary tissue during early fetal development. Medical evaluation can include visual inspection and imaging to differentiate them from moles or other skin anomalies. Though uncommon, such traits are important for genetic and developmental studies, as they provide insight into embryonic tissue differentiation and mammary ridge formation. Understanding the variations in nipple number helps researchers study signaling pathways, hormonal influences, and genetic factors governing mammary tissue growth. Number 2. Dallas Wiens, face transplant. Dallas Wiens, born in 1985 in the United States, suffered a catastrophic high-voltage electrical injury in 2008 that resulted in the complete loss of his facial tissue. 3 years later, in 2011, he underwent a full-face transplant, a complex form of composite tissue allotransplantation, CTA. This procedure involved transplanting skin, underlying connective tissue, muscles, and portions of skeletal support from a deceased donor. Surgeons meticulously connected blood vessels and nerves to restore circulation and some motor and sensory function. Post-operative care included immunosuppressive therapy to prevent graft rejection, rehabilitation to regain facial movement, and monitoring for complications such as infection or tissue failure. Wiens' case is notable in reconstructive microsurgery, as it demonstrates how CTA can restore both form and function after extensive trauma. It also contributed to research on donor selection, nerve integration, and long-term outcomes in facial transplantation. Number 1. Megan Fox, clubbed thumbs, brachydactyly type D. In Oak Ridge, Tennessee, on May 16, 1986, Megan Fox was born with a distinctive variation called brachydactyly type D, commonly known as clubbed thumbs. This condition affects the distal bone segment of each thumb, making it shorter and wider than typical, with nails that appear smaller and rounder. The anomaly arises from genetic factors influencing bone growth during early embryonic development, specifically altering ossification in the distal phalanx. Despite the altered thumb shape, this variation is generally benign and does not impair hand function. Radiographic imaging can confirm the shortened bone structure, helping differentiate it from pathological conditions. Cases like Fox's are significant in the study of skeletal variation, phenotypic diversity, and inheritance patterns, offering insight into how minor changes in embryonic development produce lasting anatomical differences. Clubbed thumbs are relatively uncommon and serve as a clear example of subtle congenital variations that persist into adulthood. Unlock a universe of stories, insights, and curiosities waiting to ignite your imagination, and make sure to subscribe to join this journey where every discovery counts. Engage by liking the content that surprises you, commenting to share ideas or questions, and sharing moments that inspire those around you. Your participation transforms these experiences into a vibrant community, and every interaction adds energy to this space. Immense thanks for showing up, for your curiosity, and for investing your time here. Your support shapes what comes next, and together we create something remarkable worth returning to every day.